Part 3 of our echocardiographic assessment will be looking at Doppler echocardiography, and this will include color Doppler and spectral Doppler, with spectral including continuous wave and pulse wave Doppler. Regarding the assessment tool of color Doppler, one thing that we'll note to start is both the jet site and direction into the receiving chamber. Is it a central jet or is it eccentric, as these could indicate very different types of valvular pathologies? Another important part of color Doppler assessment of the valve is looking at the jet components. And there's 3 pieces of information you can get here. 1, looking at the flow convergence. 2, the vena contracta, or the narrowest part of the jet. And 3, looking at the jet area. And it's often measured as a percent of the chamber, such as the right atrium or left atrium, or the LVOT or RVOT. These 3 parts are all included in specific criteria for severe AR, such as a vena contracta width greater than 0.6 centimeters, a central jet with a width greater than 65% of the LVOT, or a large flow convergence. The next part of the Doppler assessment is using spectral Doppler to assess a valve when it's indicated, and this includes, as we mentioned, both continuous wave and pulse wave Doppler. One of the first things we'll look at with continuous wave Doppler is the density of the jet velocity signal. If there's a lot of regurgitant flow towards the jet, you'll see a greater density signal. Also, it's important to assess the contour of the jet. In both MR and TR, an early peaking or a cutoff sign can indicate a large regurgitant wave in the respective atrium and significant regurgitant jets. Also, for the aortic valve, slow onset in a parabolic shape with a longer acceleration time could indicate worse aortic stenosis, whereas this dagger-shaped waveform could indicate a dynamic LVOT obstruction. Another part of the spectral Doppler assessment includes using pulse wave Doppler to assess for flow reversal. When we're assessing both MR and TR, we're going to look for flow reversal in either the pulmonary or hepatic veins during systole. When looking for AR or pulmonic regurgitation, look in the aorta or PA branches in diastole. Other components of the assessment that we can look at are pressure halftime and also LV and RV filling dynamics for volume overload.